Hello everyone, welcome back to another video. In today's video, we are going to discuss about velocity time graph. We discussed about this topic in the previous video also, in another video where we discussed about different types of velocity time graph. This one we'll be discussing about, as the title says, non-uniform acceleration and deceleration. What happens when an object accelerates or decelerates non-uniformly? This graph seems to be a bit complicated to the students, so I'll try to break it down into simpler terms and try to clear your concept in this regard. So let us start with uniform acceleration first, or deceleration. So what is uniform acceleration? What happens when an object accelerates uniformly? Let's recall that first. So let's say we have this situation where an object is accelerating at 2 meters per second square. So we can say it's an uniform acceleration. That means the velocity of the object will increase by 2 meters per second every second. So if we draw a table like this with respect to time, it's showing that an object starts from rest, that is at 0 seconds, the velocity was 0 meters per second. At 1 second, it's 2 meters per second. 2 seconds, another 2 increases, that is 4. Then plus 2, it's becoming 6. That means the velocity is increasing uniformly with time, right? Every second, it's increasing by 2. So every time the velocity is increasing by 2. So this is a uniform acceleration. We have seen the graph for this one. If it's a velocity time graph, the graph will be a straight line through the origin with a positive gradient. If the object starts from rest, it will pass through the origin. So it will be a straight line with a positive gradient showing that the acceleration is uniform. Now, in practical cases, you might not always have uniform acceleration. You might have cases where the acceleration will vary. Acceleration might not be constant, right? And how do we solve problems related to that? How do we draw the graph in those situations? So let's take another scenario. We'll have actually 2 more scenarios where the accelerations are not uniform. So again, we take another scenario where the object starts from rest. At 0 seconds, the velocity was 0. After 1 second, the velocity increased to 2 meters per second. So we can say the acceleration is 2 meters per second square. Between 1 to 2 seconds, we find the velocity increases by 3, not by 2. You see, previously it was increasing by the same amount, but now it's increasing 2 in the first 1 second and plus 3 in the next 1 second. And then between 2 seconds and 3 seconds, from 2 to 3 seconds, the velocity increases by 4. So we can conclude between these 2 points, that is 1 second to 2 seconds, the acceleration was 3 meters per second square. From 2 seconds to 3 seconds, the acceleration was 4 meters per second square. So you see the acceleration is not uniform, it's increasing, right? So the velocity is increasing and the acceleration is also increasing. Now, keep this in mind. When an object is accelerating, doesn't matter if it's uniform, non-uniform, whatever it is, the word accelerating means the velocity of the object increases. When an object accelerates, its velocity increases. Now, the acceleration can be uniform, that is, the velocity can increase uniformly, or it can be non-uniform, where the velocity increases by different amounts every second. So this situation is one of the example of non-uniform acceleration. And then we have another situation where you see in the first 1 second, the acceleration was 10 meters per second square. The velocity increased from 0 to 10. In the next 1 second, that is from 1 to 2 seconds, the acceleration is 7 meters per second square. The velocity increased by 7. And from 2 to 3 seconds, the acceleration is 5 meters per second square. Okay, so here we see the object is still accelerating because the velocity is increasing. Here the velocity increased by 7. Here it is increasing by 5. But the acceleration is decreasing, right? Previously it was accelerating at 10 meters per second square. And at the end it's accelerating at 5 meters per second square. Okay, so this case is called increasing acceleration, where the acceleration is increasing with time. This case is called decreasing acceleration. But keep this in mind, in both cases, the object is still accelerating. Don't say in the third case the object is decelerating. Don't even think of writing it as deceleration. If you write deceleration, it's wrong because the velocity you see is still increasing. First, it was increasing 10 meters per second. Now it's increasing 7. Now it's increasing 5, but it's increasing. It's not decreasing. So we cannot say it's deceleration. So whether it be uniform acceleration, whether it be increasing acceleration or decreasing acceleration, in all cases, the velocity increases in different amounts, but they all increase. That's why we are calling all of them acceleration, but of different categories. I hope the concept is clear up to here. So if you're clear up to this part, we will now shift on to the graphs. How would the graph of part B and part C look like? Okay. All right. Okay. So the first graph that we'll be drawing is for increasing acceleration that we saw here, right? The values that we have taken here, we'll be plotting that in a graph. So what we saw here is at starting point, that is at 0 seconds, the object was at rest, 0 meters per second. After 1 second, the velocity was 2. So let me just quickly try to plot it here. So after 1 second, the velocity was 2. After 2 seconds, the velocity became 5, and after 3 seconds it became 9. So after 2 seconds the velocity is 5, after 3 seconds it's 9, and let's say after 4 seconds it becomes 14. Okay, I haven't drawn the 4th second in the previous diagram, but let's just take the value here, right? So we see that the values are showing the velocity increased by a small amount after first second. After the second second, that is after 2 seconds, the velocity increased a bit more from 2 to 5. Then after the third second, it increased a bit further more from 5 to 9, and then from 9 to 14, right? If you plot a graph and then draw it, the graph would have a shape roughly like this. It's not a straight line, it's a curved line, and you see the gradient of the graph is increasing, right? I cannot draw it very accurately here because I'm not using a graph paper, but the shape would remain like this. It would be a curved line, right? So if I draw only the shape of the graph and not put down any values, this is how the graph would look like. So let me just draw it here. Graph would look somewhat like, let me just redraw it here, sorry. Like this. Okay. Fresh. Yeah, somewhat like this. You can't make it a very straight vertical line, that would be wrong. So you level the axis, velocity in meters per second, time in seconds, and the graph would be a curved line with an increasing gradient. You see, as you go with the time, the gradient here was a bit less, the line was flat, but here the gradient is more, the line is more steeper, and we know the gradient of a velocity time graph gives us the acceleration, right? So you can say the acceleration here at this point of the graph is lower compared to the acceleration here. The acceleration is higher. Why? Because the gradient is more. So more the gradient, larger is the acceleration. So this graph is showing that with time, your acceleration is increasing. That means it's an increasing acceleration graph. So if you draw the graph for the second case, that is increasing acceleration, this is how the shape of the graph would look like. All right. I hope the concept is clear for everyone. Now let's go to the last situation, the number C, where we saw that the acceleration is decreasing. It's a decreasing acceleration situation, right? So let us quickly plot the graph of that one and let's see how does the shape show up. All right. Okay. So for number C, you see that the velocity was changing. It is increasing, but by a smaller amount with time. That is, at 0 seconds, the object was at rest, 0 meters per second. After 1 second, it became 10 meters per second. After 2 seconds, 17. And after 3 seconds, it's 22, right? So if we plot it in the graph, you see after 1 second, the velocity increased very quickly, right? It became 10. After 2 seconds, it still increased, but by a smaller amount. How much was it? It was 17. So you see the interval is decreasing. Here, the interval was 10. Now the interval is only 7. And from 2 to 3 seconds, the velocity became 22. So the gap is further less. So we can say that the object is accelerating. Why? Because the line is increasing. It's showing that the velocity is increasing. And that's why it's accelerating. But how is the gradient changing? If you find the gradient at this part of the graph, this part, the gradient is more, right? The line is more steeper. And if you find the gradient here, You see, the gradient is less here. That means the acceleration is lower at this point compared to the acceleration at this point. This point, the acceleration is higher because the gradient is more. This is showing that the object's acceleration is decreasing. Keep this in mind. We say that the acceleration is decreasing. We cannot say that it's decelerating. Don't make that mistake saying that it's decelerating. So these are the types of craft that you have to understand when the object has a non-uniform acceleration. For non-uniform deceleration, we'll cover it in another part of the video, not in the same video. We'll have another video for this same topic. But in this video, we will be only discussing about non-uniform acceleration. So non-uniform acceleration, we will be studying about two types of it. One is increasing, the other one is decreasing. The increasing acceleration is shown by a curved line with an increasing gradient. And for a decreasing acceleration is still a curved line with a positive gradient, of course, but the gradient is decreasing. In both cases, the line is going to move in the higher direction, showing that the velocity is increasing and it's accelerating. It's just the type of acceleration is different. Okay, so I hope the video is clear to you. You have understood the topic and you can now draw the graph showing non-uniform acceleration for an object depending on what type of motion they were having. In the next video, we will be talking about non-uniform deceleration, where you will see what happens when an object decelerates non-uniformly. All right. I hope the video can help you out in solving your question papers and different concepts and clarify whatever problem you had regarding non-uniform acceleration. Thank you for watching the video. Stay tuned for the next part of the video where we'll be talking about non-uniform deceleration. Thank you, everyone. See you soon.